Hi guys, I hope you're good since last video. We have seen how labels could be used in a smart way to influence the resources dispatching in our Kubernetes cluster, also the affinity to have even more control. Talking about controls, you will see during this video a concept that I haven't seen yet in social medias about Kubernetes, which will help you to debug some tricky behaviors while using those labels on resources. This to learn about a pattern that is important to get from the beginning to even use it at your own advantage on rare cases. Retain this pattern: pods, ReplicaSets, deployments. Open your terminal if you want to follow along, or just get some tea and watch peacefully. I've left a link in the bio for the students who want to learn AI by doing, beginner devs who want to think at service they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download on the video. Link is in the pinned comment or video description. Get it now from our hub, check our houses. Also, please like and subscribe. Thank you for your support. Let's get started. Pods, ReplicaSets. So here we are going to start by just checking the cluster, labels. We have a label here that we're going to target, the node 1, which is location, Jigoka, which is a neighbor in Tokyo. We're going to create the boilerplate pod, which is called Nginx Jigoka standalone. So krun, the name of the pod, the image is Nginx. We do a dry run. You can put client to not get the warning error, and we output in a YAML file. We're going to generate this in a file that we're going to just give the name Nginx Jigoka YAML. Now we are in this file. We're just going to label this file and customize it a bit, just to make it lighter, have less lines that we don't, just get rid of the lines that we don't need, so that we can clearly see what is required and what is important for us here. Okay, so this is cleaner, there's less lines, it's gonna work. We just change here the label. The label is gonna be with a key app, and Nginx has a value. Let's do the same here for the container. So just the name is Nginx Jigoka standalone, just to say that is a standalone pod. Let's save this file. Open the terminal again. So we're going to be applying this file to the cluster. But before, we can maybe use what we've learned in previous videos. We can add a node selector, location, Jigoka, as it is a Nginx Jigoka standalone pod. Let's select the node which has this label. So we're expecting here to have this pod being scheduled in the node which has the same label. Has been created, we just check. Alright, and we got it on node 1, so that's where it should be. That's perfect, has worked well. Let's say you have an AI application and you have GPUs only on node 1. So you want to control where your app is going to be deployed for better performance. That's an example. Here we're going to be also creating a boilerplate of a deployment that we're going to remix. So create deployment, we're going to call it Nginx special RS because it's going to become a replica set, image Nginx, the replica count 2, we dry run it, output YAML, and we're going to output it in a file called Nginx ReplicaSet YAML. Make it just simple and easy. Let's open it. Okay, I got it now. We're going to do the same process here. We're going to make this YAML file lighter with only the required fields for this tutorial. And after we are going to change the kind also for replica set. So let's change the kind now so we don't forget it. So kind replica set. We get rid of this field. We get rid of the strategy, the creation timestamp, resource status. Are we good? So the app label, I'm just gonna use Nginx. Match label, selector Nginx. And here the template also app Nginx. Okay, so just the name is Nginx special replica set, which is a kind of replica set. And that's the label that we use. It's very important here, the label app Nginx. Match the label and the template, which is here. Okay. So it has a selector match label app Nginx. This replica set, we're going to also use the node selector on it so that we can put it in the namespace. I mean, in the node, which has the label location Jigoka. In terms of namespace, we're just working on the default namespace because that's the concept in which we're working is just to show what's going to happen. So here we have the replica sets created. We have 2. But as you can see here, we have the standalone pod, which has been acquired by the replica set. So it's part of those 2 replicas that we have requested. So why is that? Normally the replica set has to create its own Nginx special RS pods. So we should see 2 of those, but we see only 1. And the other one is the pod that I have deployed earlier. Let's just get the replica set, keys and pass. Just going to check. The owners of those. Maybe that's not the right way to do it. Just let me change this. So what I'm expecting here is to see that the owner of the standalone pod is not a standalone pod anymore. And I want to prove here that it has been acquired by the replica set. And there is a field called metadata owner references that shows that, but you can also use the describe one. So I might have done a typo, but let's see here. So we have the description of the pod, the node selector location Jigoka. That's why it's in the node 1. Maybe we can see it at the top. So here, Nginx standalone, default, and the node is on node 1 because we have the right label. The label is app Nginx, which is the same label that we have used in the replica set, And here we can see controlled by ReplicaSet Agentic special RS. So the ReplicaSet took ownership of this pod. And now this pod is under the control of that ReplicaSet. So just let me here change, because there were a typo in metadata. Now we got the settings as I wanted to see it. Okay, and here controller true, kind ReplicaSet, and the name of the ReplicaSet controlling this pod. After there is a UID for that. Okay, so pod ReplicaSet. If there is the same label, the selector of the ReplicaSet is the same, it's going to be acquired. Please like and subscribe during the break. And now let's see ReplicaSet and deployments. Let's do the same. We create a boilerplate that we are going to customize. So here we're going to create a deployment that is Nginx deployment boss, because this is the boss of them all. The image is Nginx. The replicas, we want 3 of those. We dry run it. So this deployment is going to stay kind deployment. And after here, Nginx deployment .yml will be the name of the file. So you see, if dry run you don't use equal client, you get this warning, but it's okay. No trouble at all for that. So just let me go in the right folder to open it. Just want to see what it's in. Okay, so has been created in this folder. So I should be able to open it from the folder ReplicaSet pod acquisition. Let me find it, because I don't know where am I. Okay, I got it. Okay, and now we can open it. Now let's do our little customization of this file. So when you are on those tutorials, you need to chill out and be patient, because I'm trying to show you also what goes wrong. I mean, not everything, but you're going to see a little bit of it. Okay, so here we have the label, app Nginx, the selector match label, that's the one which is going to be taking control of those containers, the pods, so everything is the same. We use the selector, just the name here is a deployment, kind of deployment, and this is called the Nginx deployment bus. Location Jigwalker, just keep it simple. Everything's going to be in that node 1. We have our fictional AI app. I'm using Nginx because it's lightweight, so that I can do those demonstrations and use a cluster with 1 controller and 2 worker nodes. So we're good. Now we can just get the pods. Okay, so we have 2. Get the ReplicaSets. 1 ReplicaSet with 2 desired, 2 current, and 2 ready. Let's apply this deployment to the cluster and see what's going to happen. You see, the ReplicaSet now has been scaled out to 2. The standalone pod is still present, and you can see here it's the same ReplicaSet. It's not called deployment, Nginx deployment. It's called Nginx special replica set. Okay, we're going to just describe it. The selector app Nginx, so it's going to select all the pods having app Nginx, and is controlled by the deployment Nginx deployment bus. So the deployment can acquire a replica set. So it has acquired the previous replica set, which is very interesting to see. So from here, you can play with it and see what's the behavior, what's going to happen. Because the older pod is going to stay alive when you delete some pods. So this is the standalone one, which is still under the control. Let's do a scaling in. So we're going to reduce the replicas to see what's going to happen. There are 3 replicas. We scale the deployment, so the upper level. That's the one, Nginx deployment bus. So now it has been scaled to 2. And you see we still have the standalone pod alive because it's the oldest. See, 14 minutes. While one of the Nginx special replica sets has been deleted because we want only 2. Let's keep going with our scaling down. Let's scale down to 1. And we have, as expected, the older pod still alive, which is the standalone one. Okay. So I'm going to delete the standalone pod to see what's going to happen. And this is our kind of high availability. A new pod has been created with the replica set still Nginx special RS, as you can see. So it still has control on that because that replica set still exists and still able to recreate some pods. I'm going to recreate it now. And you see when I recreate the standalone pod, it's killed. You don't see it coming alive because there's already one pod with the same label. I'm going to recreate and see now what's going to happen. Scale replicas to 2. So let's scale out. Deployment. Standalone pod. Try to deploy it. Standalone pod is not in anymore. You won't be able to deploy it anymore because the replica set is controlled by the deployment. Bring it back to 0. I try again to get that standalone pod in the cluster. Okay, just once it's okay, but there's no resources because we bring it back to 0. So now let's see what's the behavior when we delete the deployment. Recreate the standalone pod. Standalone pod now is being created. Why? Because when we deleted that deployment, we deleted the replica set with it because it had control on that replica set. Okay, so you see there's no more any replica set. So get RS, nothing found. And let's see now if we create this deployment. It doesn't take control on the standalone pod. It has created its 3 replicas. So here you can see that from a deployment, you can't take control of a pod. From a deployment, you take control of a ReplicaSet. Okay, so we can check if this pod is under control. Metadata, owner, references. So just pause the video to run the same commands. Okay, get pod, Nginx deployment boss. And I check for the other one. Owner references. So let me do it right, as you see. Okay, no more typo. Now we got it. And we can see that those ones are under the control of the ReplicaSet Nginx deployment bus. So now is the deployment on ReplicaSet, which is controlling those pods. There's nothing in between, because deployments are implementing ReplicaSets. It's part of those kind of resources which are implementing that. So I delete the deployment, one pod, but you get another one recreated. We got our high availability, but we have the full workload in one node. So you better get that workload in several nodes. But in our scenario, that's how we work, because you want to use the selectors. We apply the ReplicaSet, but because the deployment has been already full, the ReplicaSet will be deployed but will stay at 0. There won't be any pods because they have the same number of they have the same label. So it's not gonna be able to deploy any pods, because with that label, the deployment has already 3 pods deployed. So let me try to scale it to see if it's gonna take over. You just see that when you create the deployment first, and after you bring a ReplicaSet, there's no control done, just the ReplicaSet will exist, but won't be able to create any replicas. So that's what's happened. Here I have scaled out to 4, but because the deployment is set to 3, nothing will be able to be deployed. The deployment has a precedence on that. Okay, and you see, when I delete the deployment, at this time the ReplicaSet Nginx special errors disappears. So it couldn't scale out because the deployment was watching on it, had control over it. Pods, ReplicaSets, deployments. What I have told you in the introduction of this video now makes more sense. Standalone pods can be acquired by ReplicaSets, and the last by deployments using corresponding labels. This is a tricky behavior that you needed for you to feel more comfortable with Kubernetes. I don't know you, but I found this fascinating. I prefer to use deployment though, as I can roll out and work with high availability for my AI applications. Let's see which topic to explore next on Kubernetes. Okay, let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.